Okay, let's get started. So welcome to our review meeting for the 1.33 release. We start with Dimitar today, talking about default DNS secret configuration via the Seed API. Then we have Ismail with the ShootMutator admission plugin. Alexander talks about the new feature for supporting multiple operation annotations in the Shoot. I will quickly go over the new Garden upgrade guide. Then we have Tim with the resource references in the Garden API. And finally, Nikki with the optimized logging stack performance. So with this, Dimitar, please get started.
Hello, everybody. Today I will present, as Rafael already mentioned, the explicit domain configuration per seats. So this is a rather small change in terms of functionality. I have not prepared a demo, but I will try to justify the change and maybe go through the more important parts of it. So what is basically changing with this? We are introducing, similar to what was already presented in a previous meeting for the internal domain configurations. We're introducing an explicit API in the seed object that is under spec DNS defaults, where operators can explicitly configure the domain settings which are going to be used by this specific seed. Previously, we were relying on the global configurations, which were set via annotations in the secret resources. So now we have some distinction between the seeds. You can also set different credentials for the different seeds, handling different subdomains, etc. So with that, I'll go through quickly through these 3 points. What has changed? So as I already mentioned, we introduced this DNS defaults field in the seed, and now it is expected from operators to configure that explicitly. As of now, Gardenlet performs an automatic population of the fields on startup. So basically, when the Gardenlet starts, it will fetch the secrets. If the field is not already explicitly configured, the Gardenlet will fetch the secrets that have default domain role set as a label, and will populate the field in its seed object, but that is going to be removed in a future version. So why are we doing that? First, explicit API is, in my opinion, always easier to understand by operators. It's easier to validate, also easier to comprehend and find document. In addition, it can be configured to use separate domains, as I already mentioned, which means that you can logically create segregation between parts of Gardener installation. Subdomains can be also handled via separate credentials, which means that if, for example, you leak one of the credentials, then the bus radius is kind of scoped to that credential, and you don't compromise the whole installation. And maybe the least important part, but also something that was observed in the past, that sharing the same credential over the whole installation can lead to rate limiting for some DNS providers. And with this change, using separate credentials also reduces that risk. Okay, so what's next? This change actually was released, I'm not sure when, but at least 1 or 2 releases ago. So this is already part of the previous Gardener releases. So in some point, this field, the defaults will become mandatory, and GardenerNet will stop populating it automatically. So please take the time and set it in the seed manifests that you maintain. And yeah, in addition to that, because this API now supports not only secrets, but can reference a different set of credentials, we will eventually add support for workload identity through the credentials reference, in addition to what is already supported, which is only the secret API. I also have a few manifests that can show you what was the old format, what is the new. So old style configuration looked like that. So you would have a couple of secrets, maybe one, maybe more, which are labeled with this Gardener role default domain, which would mean that GardenerNet will select those and use those for the DNS settings. And also here you can see that provider, the domain, and priority and potentially zone all are set by labels. The new format looks like this. We have the secrets. They do not have any special annotations or labels, but everything is specified through the seed API. We have the defaults, and then we have an array of domain credentials. And here you might notice that we do not no longer set priority. Basically, the priority goes from the first to from top to bottom, which would be the highest priority, and this would be the lowest priority domain secret. Okay, so with that, I think I have nothing more to share for today. So if you have any questions, please go ahead and ask them.
All right, no questions. Ben, thanks for presenting, Dimitar. And over to Ismail for the next topic, ShootMutator admission plugin.
Hi folks, I hope you can see my screen. Yeah, today I want to share about this issue, the ShootMutator admission plugin. I also don't have a demo, but instead prepared a small document to share what was our motivation, what we changed, and why. So yeah, it's not really a new feature, but it's rather a small win for me because we managed to address the technical debt that we had in the validation area. So I firstly want to give a little bit context. In the Gardener API server, for resources served by the Gardener API server, validation can be performed. The recommended ways to perform validation are 2, in the storage layer or in entry admission plugins. So when to use which of the approaches, the validation guide states the following. You should use entry admission plugin if the validation logic requires checking the presence of another resource or the specification of another resource. If we have to give an example for this, for example, the shoot spec region fields, it cannot be validated without checking if the cloud provider, if the cloud profile resource supports this region. yeah, you might also find many other examples. Many fields in the shoot spec have to be validated against the quote profile or against the seed resource. And for these resources, for this type of validation, we use entry admission plugins. For everything else that can be validated standalone and on its own, we use the validation in the storage layer. It's actually a issue created in 2020 about the shoot validator performing mutations, and let's see what was wrong with this admission plugin. Okay, the first motivation was that it was performing, or we had an example where we perform validation in mutating admission plugin. The validation guide states the following. You have to perform validation in validating admission plugins, and you should not use mutating admission plugins for validation purposes. What's the rationale behind this? Here I built order of execution of Gartner, or order of execution of a request in the Gartner API server with regards to validation and mutations. You can see that the entry mutating admission plugins are the first step in the flow, and entry validating admission plugins are one of the last steps. So if you perform validation, for example, in entry mutating admission plugins, later on the resource might be mutated in mutating admission policies, in mutating webhooks, and you simply won't be able to validate these mutations if you perform them in mutating admission plugin. So that's why it's important to use validating admission plugins for validation. And additionally, validating admission plugins, they are not allowed to mutate the requests by definition. So by using validating admission plugin, you are safeguarded, so to say, against accidental mutations in the plugin. The next thing with regards to shoot validator admission plugin was its name, the contradiction between its name and its type. The name suggests that it's a validating admission plugin, but it was actually a mutating one. So if you are an operator which is not very familiar with the admission plugin and what it does, you might consider that it performs only validation, you disable it, but you then find out that it was later on doing really important defaulting tasks along the way, which are required, for example, for you. Yeah, I listed all the defaultings that it performs. I won't go over each of them, but yeah, the most important ones are it defaults, for example, the shoot Kubernetes version. If you omit these fields, or if you specify, for example, only major and minor version, it will populate the patch version. The same is also true for the machine image version. The next motivation for the split of the shoot validator admission plugin was that it's a relatively complex one. In the past, we had regressions in it because it's not really easy to find your way. It was pretty long. Here I listed how long with regards to lines of code it was before and how long it is now after the split. So yeah, the complexity is also reduced along the way. Especially I was having difficulties in the unit tests, changing the unit tests, adding and so on. Yeah, this is a little bit improved now with the split. The next motivation is, of course, better separation of concerns. After the ShootMutator admission plugin introduction, you can, for example, now choose, I don't want defaulting operations, I only disable this admission plugin. Or if you want to disable only the validation, you can now disable the shoot validator. So you have this fine-grained control, so to say. And the final motivation was addressing code smells. We had several functions in the shoot validator which were named validate something, but inside they had side effects and they were performing mutations. Here I listed two such functions, and which is obviously not very nice to the reader, and as developer you don't expect a validate function to perform such mutations. Okay, what we did and how we did it. We wanted the final result to be the following: all mutations from the shoot validator, we wanted to move them into a new from the shoot validator to move them to a new ShootMutator admission plugin. The type of this admission plugin is mutating, and after that we wanted the shoot validator admission plugin to be only validating one without any side effects and any mutations. How we did it? The first step was to identify all mutations which were performed by the shoot validator admission plugin. The next step was to introduce an empty ShootMutator admission plugin. Yeah, here to say the order is important. The ShootMutator has to be executed before the shoot validator. Mutations first, then validation. Because at that point of the time, they were both mutating. And yeah, then one by one in several PRs, we moved mutations from the shoot validator to ShootMutator. And after all mutations were moved, we made the shoot validator admission plugin really a validating one, so that now the name and the type of the plugin match. Yeah, that's all. Finally, as next steps, we were able to identify 2 more mutating admission plugins, which can be improved. Because they also do both mutations and validations at the same time, the main seed and the shoot DNS, and now the focus is to also improve them. That's all from my side. Thank you for listening to me. In case you have questions.
Right, no questions. Then we continue with Alexander and support for multiple operation annotations.
Okay, let me just share. Okay, you should now see. So this is the PR I will present. Now with this PR, Garner Cloud operations and maintenance operations for the shoot, and for the garden only the Garner Cloud operations can now be run in parallel. This can be done with listing them separated with a semicolon as shown here. We also have a list of all the operations that can be run in parallel in our documentation. They can be seen right here, and they are mostly credentials operations. We already had a single operations that run all of these in parallel. It was the rotate credential start, but now with the semicolon approach, we'll be able to flexibly only select the ones we want to do. I have a short demo to show as well. Here on the local step, I have workerless shoot, which now will annotate with the, let me just go a bit. It was a previous one. Yeah, right here. With the Garner cloud operation, where we have the rotate encryption key and rotate observability credentials annotations, and let me just start them, and now you have a shoot reconciliation. And if we check the shoot status, we see that those two operations have started simultaneously. And as I said, we can also configure the maintenance annotation as well to be having parallel operations. But let me just change to something else, like the start. Yes, and now in our next maintenance window, we'll have these two be promoted to the regular Garner operation and be started in the maintenance window. And here we can see them in the operations. Yes, right here. And on a side note, to avoid overloading the app server, we deny on validation the first inappropriate operation. That, for example, if we not allowed operation, if we have bar, oh yeah, at the moment I can't show, but maybe if I just see the operation, yeah, we have a validation error only for the first value. And this approach will help us for future features, like doing an automated rotation in the maintenance window, where we can have multiple credentials to be rotated, selected by the user. Okay, this was about it. Any questions?
Nope. Cool. Then let's continue. Next up is the Gardener upgrade guide presented by me. So this is actually about this PR, so Markdown document, no demo here. And I also want to keep it short because it's a lot of text here and I don't want to read it out. Just want to raise some awareness that we now have this guide for upgrading Gardener. So what you need to do when there is a new Gardener release, because we have multiple components like the Gardener operator, the control plane, the gardenlets, and this all propagates down to the seeds then there and so on, extensions. And it was not quite obvious for people that are not too familiar with the development and everything, that just use Gardener and deploy it. What's the recommended way is to perform these upgrades. So there are basically 4 sections here. First one is to preparing before touching anything, raising awareness about our version skew policy. So this is actually another document that we already have for quite a while, similar also to the one that Kubernetes has. So they are very similar as said. And they talk about what are the version differences that we support for Gardener API server and the other control plane components, and also for the Gardenlet then, for the Gardener operator, and what is the supported component upgrade order and so on. If you have not seen it, maybe it's a good idea to go through it once and make yourself familiar with it. So this is one thing. Then also a section about reading the release notes of a new Gardener release. Here we also clarify the audiences that we use. And for people that are just deploying Gardener, the focus is of course on operator and user mostly. Then there's a section about deprecations and backwards compatibilities. So how we handle these things when we have to change something. Also here we already have an existing document which is this one, releases, features, and hotfixes. There's a section here about deprecations and backwards compatibility, also existing since quite a while. And here we explain that usually changes relevant for end users should be connected to a Kubernetes version, a minor version upgrade, how we do it for Gardener extensions, and so on. I think it's summarized here. And it talks about the fact that, of course, breaking changes should be applied to the manifests before updating the version numbers of Gardener. And then finally, the second step is here upgrading operator first, which then upgrades the Gardener control plane. So we don't talk about the legacy approach of deploying the Gardener control plane directly via its Helm chart, because this is already deprecated and planned for removal in a couple of weeks. So we only document the Gardener operator approach and way of managing Gardener. So there's a section about image vector overrides, about extensions, how to verify the readiness of the garden resource, so how to know that the rollout has been completed, checking the last operation and the conditions and so on. Then next step is upgrading the gardenlets. There are different topologies, unmanaged seeds, how they are upgraded, managed seeds. But this is all not quite obvious for people how this all propagates. Also, for example, that we have this jitter period here for managed seeds, that not all gardenlets are there updated at the same time, and how this can be configured. Again, how to verify the readiness that this has completed. And then finally, a word about shoot reconciliations and how the shoot clusters are upgraded, that there's this reconcile and maintenance time window, and the step that we should make sure that all the shoots have been reconciled before upgrading to the next Gardener version. And finally, the last part is then about the operating system config updates, because also there we have some jittering which can be configured with this annotation on the shoot, because people were wondering why this sometimes takes so long to roll everything out. And that's basically the guide currently. It might not be complete. If you have ideas what else could be interesting in this upgrade process, feel free to submit a PR to it. That's just the initial thoughts that we had and the initial feedback we got. So at least we now have something and can iterate on it and improve it on the way. Any questions? Cool, thanks. Then I would like to hand over to Tim for the resource references in the Garden API.
Yep. Hello, everyone. Thank you, Raphael. So this one is about a new API enhancement that we added in the last release. It's something that's already part of the seed and the shoot API, and now we added it also for consistency reasons to the Garden API. Concretely, it looks like the following. So in the Garden API or in the Garden resource, you have the spec, and now you can configure resources and reference config maps as well as secrets in this section. So in this example, we're referencing a secret with this name and another config map with this name. And the main motivation is that extension configurations within the same resource can reference to it. So for instance, we have one example extension, and in the provider config, it references the secret in the config map that is then defined in the resources section. As I said, we already have this in the seed and in the shoot API. And now it's also in the Garden API. So when extensions are able to run for the Garden cluster, then they can use their very same provider config yeah, earlier they needed to change this somehow to reference it in a different way, and now they can stay in the same API. Okay. What happens behind the scenes is, so we can, I'm in the runtime cluster right now, and we can create a config map. Just some config here. Oh, sorry, I need to create it in the Garden namespace. Okay. So it's just an empty config map, right? Nothing happened to it. Then we can edit the Garden resource. Let's jump to spec. Resources. Let me copy it from here. Okay, so I only do this example with the config map right now. And yeah, we see that a finalizer has been added to the config map because it's being referenced by the Garden resource. So this is what happened behind the scenes. And if we check again, we see that we only have this config map in the Garden namespace. So in the seed and in the shoot case, the Gardenlet copies the config map over to the seed cluster and renames it a bit differently. It has a well-known prefix, but in the Garden case, nothing is copied, right? So you only reference it via the Garden resource, and the original resource stays in the runtime cluster. So if the extension running in the runtime cluster wants to make use of this config map, it really needs to pick it up with the same name inside the same cluster, of course. Okay. That's it for the resource section.
I just have one small questions. Yeah, I recall that one of the motivations for having resources on shoot level was this control plane migration scenario, just so that Gardenlet can restore all these reference resources in the target seed. Do we have added value to have these resources in the Garden resource, except that for extension, it's some consistent and unified way to read the resources. Yeah, I was wondering if there's some other reason other than the unified way how you access them.
Yeah, the added value is that the extension does not change the API it's providing. So it can change the same API for the shoot, maybe for the seed, and also for the Garden right now. So if we hadn't this resource section, it would have needed to come up with a different API, maybe with a different field like secret ref, then referencing the namespace of the secret as well, stuff like this maybe.
Okay,
but this is the added value in this case.
Got it. Thank you.
You're welcome.
All right, cool. Thanks. Then one more topic for today. Nikki with the optimized logging stack performance.
Yep, let me share. A second. Sharing. Right. to tune a bit the teams. Right. Okay. So in the latest release of the logging stack, we had to tune it a bit to accommodate a new increased volume of logs that we have seen in certain environments. And that was not that interesting. But the more interesting part is that actually I took the opportunity to redesign entirely the current default v1.133 dashboard. So I don't have a previous snapshot of it, but it's basically a rewrite from scratch. And now it really contains more information on what is happening, at least in the logging stack. And I'll briefly explain the three sections that are currently visible in the v1.1. This dashboard and that information is a particular use of the operators who are monitoring or wanting to take a look at what is going on seeds. There is three major sections, I would say. One is the v1.1 itself in the dashboard. The other one is more dedicated, or let's say more detailed view on the delivery or routing or shipping of the logs into different control plane namespaces. And this is the output plugin dashboarding. And in this particular version, of course, the clients of the output plugins that actually deliver these logs to the backend. So this is the Valitail. Just a small remark. This probably would be the last release of the v1.1 and output plugins, which are in the Valitail or work with Valitails. The new major release of the login plugin will be based on OpenTelemetry and will not, of course, is backward incompatible, and we only target OTLP based backends. But okay, so let's go here. So in the v1.1, of course, what is really interesting is to see, is to monitor the input, the utilization of the input plugins. There are a couple of input plugins that are currently visible. One is related to actually reading the logs from the file system on the seed. You can easily go and check the cluster inputs, what is currently available as an input in a particular seed by leveraging the v1.1 operator resources. And if you, for example, go into more details, you can just quickly go and check what exactly is happening in the configuration of these input plugins. Basically, what you want to see as a healthy environment is that there is corresponding between the utilization of the inputs and outputs. They do not need to be on the same level. Yeah, should be possible to have some differences in the input and output pipelines of the v1.1, but on a general perspective, let's say these two things needs to look quite similar. Because I'm running this on a local Garden setup, for example, this input plugin records aggregation seems like this graph here, but the difference is that we have here an aggregation of 4 v1.1, but on a seed where we have a number of nodes, then we'll have view on each particular v1.1 for each particular node, how this load distribution would look like. And of course, here the interesting part would be if a node is going into some kind of a trouble state, then probably it will be showing up. Or maybe there is a container running on that particular node which spins logs like crazy, and then we'll easily go and see these nodes on this graph. And then again, the same for the output records. And again, as the aggregated visualization here, the full bits and the inputs and outputs needs to look kind of the same. Although, as I said, under very heavy load conditions, this might not be true. Okay, all these metrics, they come from full bits, so there is nothing from our side. We just aggregate the existing metrics which are exported by the full-bit implementation, and we visualize here, and that just give us the quite good view on whether a full-bit is healthy or not. Now, if you go into the output plugin, here now we shift a bit the view from a particular instance of full bits towards a particular instance of the works which are assigned to control plane. So, for example, here you see these URLs, and you easily recognize that would be the control plane targets that we are shipping walk to. In this example, we have only the local shoot which is present, but on a quite busy seat, you will see all the backends listed here. And again, you will see aggregation from all full bits shipping walks to that particular instance, and it shifts the focus from the single full bit instance towards, okay, give me the volume that a concrete control plane backend is receiving. And again, you can easily identify which are the top control planes which get the volumes, the most of the volume traffic to them. One particular graph that was missing in the past is this DQ current size. If you Google or just check the project on GitHub, this DQ project, it's a persistent pipeline or queue implementation in Go. And that basically is our safety net in the current logging stack towards the differences in speeds of generating logs and persisting those or ingestion in those logs into the backend. So if there is a big differences, this is accommodated, or this difference is buffered by this queuing mechanism. The problem that we had in the past is that these queues are persisted on the local file system. And that may grow if these differences in speeds of generating logs and persisting those logs are constant for a greater time. Let's say if we have days with in a situation where we have too many logs generated constantly for a very long period of times, and the ingestion speed is, let's say, 10 times less than what has been produced, this will be piled up on these queues. And in the past, we didn't have much knowledge or easy way to visualize what is the current state, but now that is visible. In the OTOP world, there is a standard mechanism for back pressure management of the OTOP exporters and receivers, and it will be a different visualization, but pretty much it will the same notion. Yeah, what are the buffers, state of the buffers in the pipeline when we had these differences. Right now, this picture is quite healthy. If we have this constant view, that's perfectly fine. If you have peaks, that's also perfectly fine. That's good. Yeah, for a very short period of time. We have some speeds, these differences in generation and perceiving, and the stack was able to catch this sudden peak of the volume and then go down, means in that it was able to ingest it. But if we see a constant going up type of graph, then that designates an issue. Again, in very heavy type of environments, for us, it took days actually to reach a troublesome state. So it's quite capable of this queuing mechanism. But yeah, if you pump up walks days in a rate which is greater than what you can ingest, then yeah, this can easily go wrong. Right. Okay. So this is the output plugin. So this is the Gardener implementation of the routing of the walks to the control plane. And finally, there is also a few metrics which are interesting about the actually the clients that chip walks to the backends. And here, to me, at least the most interesting part is this graph, the average latency. So I would say anything, usually latencies below a second are quite okay. On some of the peaks where the ingestion is really put under stress, it could go in seconds range. Let's say 15 seconds or something like that. That also I have seen. And for a short period of time, this is also quite okay, I would say. But if we have a constant average latency in the second range, then it works. Maybe it's not a problem, but at least it should be checked. Yeah, what is happening? If the load is too much, or maybe the persistency disk of the valleys, the backends have trouble, some troubles, because that also we have seen. This latency that we've seen here does not only relates to the traffic that has been put, but quite often it also has a direct relation to the IOPS operation of the persistent volumes which are attached to the backend. And on different hyperscalers, this number can differ quite a lot, I would say. Yeah, so anyway, if it goes up and stays up for a greater period of time, it's definitely, it's worth to go and check to see what is happening, either on the generating side, so there are too much volume walks that are coming in, or there is a problem with the persistency. And in general, in the previous version of the dashboard, there was no clear separation between these different views, but now you can really focus on the different aspects, which are, okay, how my fluent bits are doing, fine, not fine, how my routing of the walks or output plugins are doing, what exactly is going where, under what load, and the sending part of the concrete clients that send these or push these walks to the targets. And I think from operating perspective, it provides a greater value that what in comparison to what we had in the past. All right. That was everything from my side.
Cool. Any feedback or questions for this topic? Nope. Then that's it for today. Cool. Thanks, everybody. Thanks for joining and presenting, and see you again next week for the last review meeting of this year. Have a good time. Bye-bye.
Thank you.
Thank you, bye.
Bye-bye.